Welcome to a slow, beginner-friendly lesson on creating your first Python Lambda handler and testing it locally, made for absolute beginners. The first real handler. In the previous lesson, you learned what AWS Lambda is, a serverless service that runs your Python functions on demand. Today we write our first real handler. We open the file lambda_function.py, we define the function with the exact signature Amazon expects, and we study its three parts: the event parameter as input, the context parameter as runtime info, and the return dictionary as output. Then we test the handler locally by calling it directly, no deployment yet. Local testing first, deployment next lesson. That order keeps you calm and your account safe. Event in, response out. Where are you? You understand the Lambda model. Upload code, Amazon runs it on demand, you pay per millisecond. You have seen the handler signature, def lambda_handler with event and context. Today we turn that into real, runnable code. We create the file, we write a greeting handler, we test it locally with a sample event, and we confirm the return value looks right. Deployment comes in the next lesson. The rule is simple: make it work locally first. From ideas to code. Today we add two files to the Cloud Foundations workspace. The first is lambda_function.py inside the package. This is the file Amazon expects when you deploy. The name matters. When you zip and upload, Amazon looks for a file called lambda_function.py containing a function called lambda_handler. The second file is a test_lambda_function.py, where we verify the handler works before deploying. Both files live inside the project structure you already built. The file Amazon expects, move into the project. Confirm Boto3 is installed with uv add Boto3, and confirm PyTest is installed as a dev dependency with uv add --dev PyTest. Here is a pleasant fact: to test a Lambda handler locally, you do not need a special simulator. The handler is just a Python function. You import it, you call it with a sample event dictionary, and you check the return value. The only thing Amazon adds at runtime is the context object, and we pass none for that during local tests, because we ignore it anyway. No simulator needed. Here is how we run today's work. First, write the handler in src/cloudfoundations/lambda_function.py. Second, run the tests with uv run pytest test/test lambda_function.py-v. If you prefer the interactive route, open IPython, import the handler from the package, and call it directly with a sample event and none for the context. Both approaches work. The PyTest version is what you keep for the future. The IPython version is what you use to explore. Test before you ship. Every Lambda begins with one signature, def lambda_handler event, context. Memorize it. It is the door every function walks through. Memorize the signature. Every Lambda handler has the same structure, and we learn it in three parts. First, the signature, def lambda_handler with two parameters, event and context. Amazon requires this exact name and this exact parameter order. Second, the event parameter, a dictionary carrying the input data. Third, the context parameter, an object with runtime information from Amazon, which we mostly ignore. And the return value, a dictionary, usually with a status code and a body. Master these three parts and you can write any Lambda handler. 3 parts to master. Here is the minimum handler Amazon expects. A file called lambda_function.py containing a function called lambda_handler that takes event and context. Inside, you read from event, you do your work, and you return a dictionary. The simplest possible return is a dictionary with status code 200 and the body string OK. Even this skeleton deploys and runs. Everything else, reading input, building a richer response, is just Python you already know, layered on top of this skeleton. The minimum that runs. The event parameter is a dictionary. Whatever invokes your Lambda, a web request, a timer, a manual call, Amazon packages the input into this dictionary. You read values from it the same way you read any dictionary, with .get and a default. Here, name equals event.get name, world. If the caller passed a name, you use it. If not, you fall back to world. This prevents a crash when a key is missing. Using .get instead of square brackets is the safe habit for Lambda handlers, because you cannot always trust the input shape. Read with .get. Here is the anatomy of a handler, seen as a flow. On the left, the event arrives as a dictionary, the input to your function. In the middle, the function body does its work, reads values from the event, processes them, builds a result. On the right, the function returns a dictionary with a status code and a body. The status code is an integer that signals success or failure, 200 for success. The body is a string, usually a JSON string, carrying the actual response data. That is the entire shape. Event in, work done, response out. Everything else is detail. Event, work, response. Event in, work done, response out. The handler is a tunnel with a clear entrance and a clear exit. A tunnel with two ends. The context parameter is an object Amazon passes with runtime information. It has attributes like function name, the AWS request id, and a method called getRemainingTime in millis that tells you how many milliseconds are left before Amazon kills your function. For beginner handlers, you almost always ignore context. It exists for advanced cases, like canceling work when you are about to run out of time. In this course we never read from context. We accept it in the signature because Amazon requires it, and then we ignore it. That is completely normal. Accepted, then ignored. The return value is a dictionary. For a web-triggered lambda, you include two essential keys. Status code is an integer, 200 means success, 400 means a client error, 500 means a server error. These are the same HTTP status codes you learned about in the API lessons. Body is a string, and often that string is JSON, because the caller usually expects structured data. We build a JSON body in a moment. For now, notice that even a plain string body works. The two mandatory keys are status code and body. Two mandatory keys. Here are the status codes you use most often. 200 means OK, the request succeeded. 201 means created, you made a new resource, like a database row. 400 means bad request, the caller sent invalid input. 404 means not found, the requested resource does not exist. 500 means internal server error, your code raised an exception. These are the same codes from the HTTP basics lesson. For this course, 200 is your default. You return 400 when the input is wrong and 500 when something breaks. 200 is your default. A third key, headers, is optional but common. It is a dictionary of HTTP headers. The most useful one is content type. If your body is a JSON string, set content type to application/JSON so the caller knows how to parse it. Without this header, the caller might treat the body as plain text and fail to parse your JSON. Headers are a dictionary, the same structure as the event, just going the other direction. You learned dictionaries in the collections section, and now you see them everywhere in Lambda. Tell the caller it is JSON. Calling the function locally, with a sample event, catches mistakes before they cost a deploy. This habit pays forever. Catch mistakes early. Here is the full greeting handler, putting all three parts together. We import the JSON module. We read the name from the event with the default of world. We build a greeting message with an F string. Then we return a dictionary with status code 200, a content type header, and a body created with JSON.dumps. Notice the body is a JSON string. JSON.dumps turns a Python dictionary into a JSON string. The caller receives that string and parses it back into their own dictionary. This round trip, dumps to send, loads to receive, is the heartbeat of every API. The full picture. Here is how we test locally without deploying anything. We import the handler from the package. We write a test that builds a sample event dictionary, name equals Ada, and calls the handler directly, passing none for the context. We assert that the status code is 200 and that the body contains the name Ada. A second test calls the handler with an empty event and asserts the body contains the default world. Run these tests with UV run PyTest. If they pass, your handler works. This is the power of the handler pattern. It is just a function, so you can test it like any other function. A function is a function. The file name matters. When you deploy a Lambda, Amazon looks for a file called lambda_function.py containing a function called lambda_handler. These names are the default, and they are a convention most Lambda developers follow. When you deploy, you specify the handler as lambda_function.lambda_handler, that is filename.function name. If the file or function name does not match what you tell Amazon, the deploy fails with a runtime error. So name the file lambda_function.py and the function lambda_handler. Follow the convention and everything works. Names must match. When your Lambda sits behind an API gateway, which is how you turn it into a web endpoint, the event Amazon sends has many fields. The two most useful for beginners are HTTP method and query string parameters. HTTP method tells you whether the request was AGET, POST, or something else. Query string parameters holds the values after the question mark in the URL. So if a user visits your endpoint/greet question mark name equals Ada, the name lives at event square brackets query string parameters square brackets name. We do not wire up an API gateway in this course, but knowing the event shape prepares you for it. The event grows richer. Lambda and JSON are inseparable. The body of your return value is usually a JSON string, built with JSON.dumps. And if your event arrives with a JSON string in its body field, which happens with POST requests, you parse it back into a Python dictionary with JSON.loads. Dumps turns a dictionary into a string. Loads turns a string back into a dictionary. This round trip is the same skill you learned in the JSON lessons. The cloud does not change the Python, it just gives you more places to use it. Dumps to send, loads to read. Quick self-check. Can you write the handler's signature from memory? Can you explain why you use .get to read from event? Can you name the 2 mandatory keys in the return dictionary? Can you explain how to test a handler locally without deploying? If any feels shaky, rewatch the matching part. You should be able to write a working handler from a blank file before moving on to deployment. Say each out loud. Here is the handler in one breath. Define a function called lambda_handler that takes event and context. Read input safely with event.get, providing a default. Return a dictionary with a status code and a body, the body built with JSON.dumps. Put the code in a file called lambda_function.py. Test it locally by calling the function directly with a sample event dictionary and none for context. If the return value looks right, you are ready to deploy. One signature, one habit. Next lesson, we deploy this handler to Amazon. We package the file as a zip, we create an IAM execution role that lets the function write logs, and we run AWS Lambda create -function with the right flags. Then we invoke the function with AWS Lambda invoke and read the result from an output file. The handler you wrote today is exactly what we deploy. Local testing first, then deployment, that is the order, and you have done the first half. We deploy next. If you want hands-on practice now, do these 5 steps. Create the file lambda_function.py inside the package. Paste the greeting handler we wrote together. Create the test file. Run the tests with UV run pytest. Then open IPython, import the handler, and call it with your own name in the event. When you see a dictionary with your name in the body, the handler works. That output is your green light for the deployment lesson. Write, test, confirm. Thanks for writing your first Lambda handler. Next we deploy it to AWS and invoke it from the command line. The handler is ready.